First of all, good afternoon, everybody. I hope you had a good lunch. I hope you didn't eat too much so that the after dinner dip is not going to be too terrible. My name is Donny. Thank you for the fantastic introduction, Jeroen. I always have this slide here, and every time I think, what am I going to tell you that you didn't already just learn about me? So I'm just going to skip it a little bit. Jeroen mentioned I have 2 books that I have self-published. I have written a couple before that, but those are published under Pact, and they're kind of old by now, so I don't promote them anymore. If you want to learn more about Combine or Core Data, grab either of them or both if you want. And of course, I'm working on a book on something new, something that only makes sense to write about, given that I also wrote about Combine. Anyway, so my talk today is called Managing Combine Your Existing Code and Async Await. And there's one super new technology on this slide, which is Async Await, one relatively new one, which is Combine. And they seem to very much compete for some space in our code base, right? Combine and Async Await have a lot of overlap. And maybe even some of your existing code does a couple things that you might do with Combine or Async Await. So how do we mix them? How do we migrate from one to the other? And how does this actually work in real companies with real problems, with existing code bases often? And how do we deal with all this? And actually, as I was sitting down just now thinking about the title of this talk, I was like, this is actually kind of misleading because I'm not going to be telling you how to manage all this. It's more about introducing new frameworks and technologies into an existing code base, right? We can all learn Async Await, we can all learn Combine, we can all learn anything we want really. But then we start to think about how it actually fits our real code, and everything changes, right? Because suddenly you're not dealing with the clean slate that you were hoping for when you learned this technology. So why am I talking about this now? Because in 2019, Apple introduced Combine, and it was for iOS 13 and up. This was awesome. I remember actually being at WWDC, my first and last one, and they announced this. I was like, finally, we don't need RxSwift anymore, right? Because we didn't have any good alternatives that were native to the platform, and we wanted to do something with functional reactive programming. So now it's like, yes, we can use something native. And then they also introduced SwiftUI, so that was a fantastic week for everybody, because now we have a new UI framework. But of course, as sort of that WWDC high sort of fades and you realize what they actually did is they showed you what you can use in about 2, 3, maybe 4 years, depending on what your minimum target is. And then also you start to learn SwiftUI a little bit and you realize, SwiftUI for iOS 13 is actually still a little bit rough around the edges. But now in 2022, suddenly I get all these emails saying, hey Donny, you did a book on Combine, right? Yeah, I did. And you also do some workshops? Like, yeah, I do. Cool, can you teach us? It's like, wait, this technology is old now, right? It's 4 years old. Why are you learning it now? And of course, it makes sense because only now these companies are having iOS 13, 14 as their minimum deployment targets. They're finally putting this on their roadmap. So for them, looking at Combine and SwiftUI now makes a lot of sense. But they do have all this legacy code that they have to maintain, right? If you started a new app in the last year or two, you probably have SwiftUI Combine and all that. But if you started your app 15 years ago, or 10 years ago, or whenever you could have started it, then you're probably a little bit more cautious about introducing anything new. And of course, when they ask me about Combine, they're like, oh yeah, also, what do we do with Async Await? Because they seem to be very, very similar. So I couldn't do this talk without actually also mentioning Async Await extensively. So what are we talking about today? We're going to be exploring a little bit the current state of codebase. So we're going to do that very briefly. I'm not going to show you a lot of code, but we're going to talk about some patterns that exist in code bases today. And more importantly, we're going to look at how closures, callbacks, delegates, and all those are used in the real world, because those are actually the components or the parts of our code base that we're looking to replace when we introduce something like Combine or Async Await. I'll quickly introduce Combine, even though I'm sure that most of you have touched it in some way or another by now. You probably may not have done it extensively. So we'll quickly do an introduction there. And of course, again, we'll talk about Async Await, and I'll summarize everything for you nicely in the end so you don't forget everything I talked about. So when I look at code bases that I see in my line of work, because now that I am freelance contracting and doing all kinds of stuff that comes on my path, I see a lot of code bases. I see way more code bases than I've ever seen in my life. And what's really cool is that they are of varying sizes. They use different architectures. Some are really good, some are a little bit less great, and that's why people ask me and others to come in and help improve the code base. But in the end, these are existing code bases that all have a legacy, they all have a story, and you can't just throw them out, right? That would take maybe years of rewriting, and you're probably going to make a lot of mistakes. So you have to think about how to introduce code in a sensible way in these code bases. And for that reason, these existing code bases, they can't just say, oh, hey, you know what, let's introduce combine here, or let's start using SwiftUI right now, let's do it. Because it's a lot harder to introduce new technology if you have a lot of legacy. And even though all these code bases are vastly different, they all use similar patterns, right? Especially when it comes to like their asynchronous programming. They will use basically one of three kind of things that you can use: closures, callbacks, which are closures, or delegates, right? These are always present in the code base in one way or another. And of course, I'm ignoring the fact that some code bases might have RxSwift here. Just putting that aside for now. So let's take a look at code that we have all probably written at some point in one way or the other. The most boring example of asynchronous programming, a network call. We want to load some data, we pass a completion handler to the function. Right, we make a URL, we actually execute our data task, and when things went well or terribly wrong, we call our completion handler with a result type. This is something that I have seen in many shapes and forms, but it's almost always some functions that take callbacks and either take results or not. That part's a little bit less often. But using a function like this, we call the load data function, we pass in the closure, it receives an argument, right? This doesn't look too crazy to anybody. Like I said, this is probably the most common use of closures that I've seen. And it's actually a very useful tool in asynchronous programming to say, hey, you know what, you go off and do some work somewhere else. I really don't care where you do it or how long it takes. Just tell me when it's done. Call this closure, give me a result back, and I'll figure out what to do from there. And combined with result, that is a really powerful pattern. Right, so a completion handler is always called when some async operation has finished. Right? That could be immediately because maybe we're not meeting certain preconditions to actually even perform any work, or it could be after the work is done. The handler could receive a result. Sometimes we don't pass the result because we just want to inform the caller that we're done now, proceed. In that case, you might not have a result, but usually you will have a result of your operation. And this is an important one. We expect this handler to be called once. Right? A network call goes off, does the work, fetches data, then tells you that it's done. It won't finish more than once, right? Because you can only go to the network and come back one time. So a slightly less common but still useful use of closures could be something that allows you to track changes to some state, right? In this case, I have some code that has a variable tracks. Maybe that's music tracks, maybe train tracks, whatever you like. And we have a closure, and that closure is called whenever we assign something new to these tracks. And that can happen once or many times. Right, so using this code, we make an instance of our view model, we assign something to onTracksChanged, and whenever tracks changes, we could update UI, we could do whatever we want. Of course, in SwiftUI, the UI would update automatically, but if we're still doing UIKit code, we would have to do something like this to manually tell the UI to update. So this use of closures as sort of a change handler allows us to provide some handler or observer that is called whenever some property changes. We can't really use this exact pattern if multiple objects in our code base wants to know about these changes, right? Let's say that this one view model is used in 3 screens, then not all 3 screens would be able to pass this closure. We can fix that, of course, by having some array or whatever, but out of the box, this wouldn't work. And basically what I just showed you is a very, very rudimentary form of reactive programming. We're saying whenever this thing changes, give me a new value. And we're going to keep getting values until whatever, until that object goes off screen, for example, or until the property no longer changes for any reason. And this closure we expect to be called multiple times, or not at all. Right? It can be called more than once, as opposed to a completion handler, which we would be very confused if that is called more than one time. So let's put these two kinds of closures side by side. One is a completion handler. It's called once. It signals completion of some kinds. It can communicate a result. If we look at the change handler, that is called anywhere between 0 and infinity times, depending on how often the property that we're observing changes. It signals that something changed or a value was changed or new data was obtained. And it can communicate this new value back to us. And as you can imagine, these two completely different uses of closures and these two completely different use cases of sort of asynchronous programming require completely different migration paths. We can't just take what we do for completion handlers and apply that to the other one. However, there are some things that no matter what we do and which technology we choose to introduce into our code bases that we should always keep in mind. We should try to avoid breaking our existing code. Of course, you're going to break some things at some point, but what you really don't want to do is, if you're refactoring your data layer, is start at the core of that, make that combine based, because now you're stuck refactoring everything that depends on it and everything that calls it to be combine based as well. So you want to figure out a path where you can introduce a technology like combine without having to refactor everything that depends on everything, or everything that depends on anything, I should say. We want to adopt these new technologies slowly. And the reason we want to do this is if we have an existing code base, and that code base could be really big, you don't want to jump into anything. You want to sort of see how it works for you and slowly make changes to how you're implementing this new technology. We also want to duplicate as little as possible. You could say, well, we'll have our legacy networking stack and we'll have our combine-based networking stack. We can copy-paste that and start adding methods to the other one. And now if we want to make a change, we have to make it in two places, but it's fine because we never forget anything. Spoiler, you will forget to update one of the two. But before we start looking at an example, let's do a little combine speed run. Right. If you have never seen combine before, you'll probably still be a little confused by the end of this speed run, but hopefully you understand enough to follow along with what I'm trying to show you. So combine is called a functional reactive programming framework, and that means that we use so-called pure functions to transform values into new values. What that means is that we apply operators like map, flat map, compact map, all those different kinds of operators to a stream of values, just like you would in an array, and we transform these values. And I say pure functions because we're not supposed to rely on anything outside of the closure. So if we were given a string, we can transform that into anything we want, but we shouldn't be relying on anything that exists outside of the scope of that closure. In practice, you might actually do that. In theory, you shouldn't. We can also apply timing-based operators. So that means that we can say, if somebody's typing into a search box, the user is typing really quick, wait for the user to not do anything for roughly 0.2, 0.3 seconds before we actually kick off a network call to go fetch the search results. A publisher is the main unit that we're dealing with in combine, and that's what provides values. Right? So we subscribe to a publisher and then we receive output from that publisher over time. And what's really cool is that we can build huge pipelines of operators. So we can say, first take this string from that piece of text, transform that into a network call, execute the network call, extract data, transform the data into a model, et cetera, until in the end we have a list of model objects. So using combine looks a little bit like this, right? This is a not too useful example on its own, but it is great to explain things. We have a set of cancellables. Cancellables are how we manage life cycles for subscriptions in combine. That might not tell you much right now, but it will be very important towards the end of the talk. So keep that in mind. We manage the life cycle of a subscription. Then I make a publisher using a property on array that I've never actually had to use yet in production code, but it is extremely useful when I want to explain something because a publisher is a lot like an array, except it gives you values over time instead of all at once. We transform the integer that we received multiplied by 2. Then we subscribe to the publisher that we've just created. We print whatever the output was, and we store that subscription into our set of cancellables. Whenever that set of cancellables is deallocated, so nobody's holding a reference to it anymore, the subscription is canceled. So that means that if we don't have that store inline, nothing will happen because by default, our subscriptions are torn down immediately unless we tell the system not to do that. So that's what that looks like. A combined publisher will emit anywhere between 0 and infinity values. Right? There is no contract in combine that says this will ever only give you one value. The publisher can also complete. It can tell you, I have emitted all the values that I wanted to emit. I'm done now. It can also tell you, I encountered an error and I cannot proceed. Right? So it will either fail or succeed, but it will complete or it will never complete. Right? In some cases, that might happen as well. Publishers can tell you about new values, right? We just saw that pipeline where I took an integer, multiplied it by 2, and then eventually subscribed to that multiplied integer. That is providing a new value. And basically, if you look at that list, a combined publisher can do both of the things that we did with completion and change handlers, right? They can tell us that something changed, that a new value was available. They can do that between 0 and infinity times. For completion handler, we only expect that to be once, but 1 is definitely somewhere in the range of 0 to infinity. So yeah, combine can replace completion and change handlers. So what's interesting here is that even though combine can replace that, and I very purposely said combine does not do, I didn't say combine does asynchronous programming. I said combine replaces completion and change handlers, because combine is not an asynchronous programming tool. It helps us do it through these pipelines, but it's not a task runner, for example. Also keep that in mind. I'll talk about why that is important later, but just keep in mind that that's the case for now. Combine basically replaces that closure part that we saw earlier. So here's that network call that I showed you earlier, right, with the completion handler. So let's say we wanted to write the exact same thing in combine. We define a function that returns any publisher. If everything goes well, it will emit some model. If something goes wrong, there's just a generic error that we would get. We make the URL, of course, and then we execute our data task. We ask URL session for a data task publisher. We extract data using map. We decode that data into some model using a default JSON decoder. And then we erase to any publisher. And we do this so that we hide the true return type from the callers of load data. If we didn't do that, we would return something like publishers.decode, generic over publishers.map, generic over publishers. Or URL session.data task publisher. Basically, we would expose everything that we did inside of this function to whoever calls it, which obviously we do not want to do, especially not if you're like Peter or Stefan building an SDK. They would hate if you saw what they did on the inside. But this is nice. This is really cool. This is the exact same thing as the code we saw before. It's a lot shorter, but doing this immediately is way too impactful because we basically threw out our old code and we replaced it with combine, which means that everything that calls this load data function in our app has to update to be combine compatible, which will eventually spiral into us rewriting the whole app and not delivering anything for months. We could say, well, this could exist alongside that, but then we run into duplication of code, which we also wanted to avoid because we can all agree that that network call was way too easy to exist in a real code base. Normally you would have authentication, you would have caching maybe. It would be a lot more complicated to actually retrieve something from the network. So how can we slowly introduce combine into our networking layer? For example, we could do it like this. We still have that load data function, and it still returns any publisher. So we haven't changed that. And the cool thing here is that when the time comes for us to actually move over to combine completely, we don't need to refactor anything except the implementation of load data. And that's really nice, because with what I'm about to show you, we can slowly introduce combine, have both implementations coexist until we're done with the old implementation and are ready to only use the new one. We use combine's future for this, and future is a publisher in combine that emits a single value. After that, it completes. It doesn't really have a contract other than it completes after emitting one value, and it takes a promise. So what we do is we call our callback-based load data function. That will give us a result, and we fulfill the promise with that result. If the result contains a success value, the any publisher that we return, or the future will emit a success value. It will emit some model, and otherwise it will throw an error. And complete with the error. And of course, we erase to any publisher here. And this is another reason why erasing to any publisher was very important to us. If we didn't do that, we would be able to say, well, load data returns a future, but then we would be stuck using a future. When in the end, really, we want to have that code that you saw before that does the network call completely on its own without the callback-based version. Right, so this is how we can bridge a callback-based function into the combined world. This pattern, even though the code here is very simple and compact, I found that you often don't need a lot more code than this when you're simply forwarding to your old implementation until you're ready to say, hey, you know what, I'm going to add a deprecation notice to the old implementation now, and as soon as I don't have any warnings anymore in my project, like, hey, you're using the old one, use the combine-based one, I can go ahead and refactor the old one completely out of my code base and only have a combine-based one. And nobody else would know other than whoever works on this piece of code. So we can slowly introduce combine with a future, which is kind of nice. It allows us to have combine and callback-based code side by side, which is really powerful, and we don't have to duplicate anything, which is really useful to make sure that we don't introduce bugs in one version of the code and not in the other one, or new features in one version, not in the other one. By erasing to any publisher, we can hide the future, or we can hide a chain of operators that we used, making a nice, stable API. And sadly, this future can only be used for one-shot actions. So the future approach is only for completion handlers, right? Because a completion handler expects to only be called once. So this is perfect for that. So what about change handlers? Well, they follow somewhat similar, but not quite the same pattern. All right, so you might remember this code from before. We had that view model of property tracks. Whenever that was set to something new, we call onTracksChanged, and we have this closure onTracksChanged that we can assign a closure to. Now this closure is really the interesting part that we're looking to replace with something else. And in doing that, we're also going to replace the tracks property a little bit, right? So we want to rewrite that to be something that combine can work with, or something that we can slowly migrate over to combine. So this is how we would use it, right? You either assign to onTracksChange whenever you need it, or you could also rewrite a tracks list view model a little bit and take the closure as an initializer parameter. So how do we replace these with combine then? This is the most straightforward approach. We can change our var tracks. It can still be private set with and annotated with the published property wrapper. What this does is it wraps it in a combine publisher that whenever we assign a new value to tracks, the publisher will say, hey, there's a new value assigned to me. Here's the new value. So that's very convenient, right? We don't have to assign a closure anymore. We don't have to implement didSet anymore. We can just do this. And you can still access the property just like you normally would. So existing code can still use that. But code that would otherwise rely on the onTracksChanged closure could now subscribe to the published property wrapper. So using this looks a little bit like this. We use viewModel.$tracks. I have a whole talk about property wrappers where I explain what the dollar means. Essentially what you need to know right now is that it extracts the publisher from the published property. Right? So whenever we assign something new, this publisher will emit a value. And we subscribe to this publisher with sync, we receive tracks, and we can use those tracks. This publisher will not complete after emitting tracks. It will keep emitting tracks as the value changes. And what's also nice is we had a problem before where I said if multiple objects want to rely on observing the tracks, we can't do it, not without completely different code. This is really nice because now multiple objects can subscribe to the $tracks publisher just fine and receive new tracks. So actually by refactoring this, we also introduced a new feature, which is kind of cool. And of course we have to store our cancellables to make sure that when the cancellables set that I haven't put on the slide here is deallocated, our subscription is torn down and we don't keep anything alive that we no longer need. So replacing change handlers with combine, you might have noticed that I did this as a breaking change, and I did that on purpose, right? Because I no longer have this whole onTracksChanged closure. And the reason I think it's fine to do that in this layer of the app where this would exist is because it's kind of limited, right? Because this is always used at or around the view level. So there's maybe one or two places that depend on such a view model instance. Refactoring that is not as impactful as changing something that sits deep at the core of your app. Right? So it's a much smaller impact. So let's look at one more combine and old school way of doing things comparison before we get to async await. And we're going to do that by building a combine-based location provider. Now, your initial instinct, if you've ever worked with combine, would be, he's going to show us how to do a custom publisher. I won't, because we don't need one. So just if you've never done CL location manager stuff before, let's look at what it looks like in the old way of doing things. But what we'll do in this section is we'll build an object that wraps location manager plus delegate. Right? So we're still going to implement things the old way, but we're going to expose something that uses combine. This object will have two publishers, one for the user's current location and one for location permissions. So whenever the user changes their permissions, we will be informed of this using Combine, which is really nice, so we can update our UI whenever without manually querying for our location permissions every time. And if you subscribe to one of these publishers, or to the current location publisher to be specific, you will receive the user's last known location and any location that follows it. So that's also very useful, that you don't have to wait for that first location to be obtained. If we had one, you'll get it immediately. So the delegate-based solution looks a little bit like this. There's a whole bunch of code, but this is really the part that I want to zoom in on for now. Initially, we have a variable current location. Right, it follows that pattern that we saw before. Whenever we assign something new, we check, do we have a new location? If yes, we call onCurrentLocationObtained, which is a closure that somebody else can assign to us. And for location permissions, we do the same thing. Right? So that is the location provider object. It doesn't really do the actual location manager observation yet. This is just so other people can get a location and permissions. The actual delegate methods look a little bit like this. Right, whenever the authorization status changes, we simply say, oh, our current location permissions equals the new authorization status. That will trigger a did set, which we'll call the closure that we had. Very convenient. And we have the same thing whenever the location manager gives us new current location. Actually, kind of simple, kind of straightforward, not that much code needed. We now have a location provider object that we can say, hey, here's a closure that you need to call whenever something changes. So we're actually perfectly set up to refactor this to a Combine-based solution. We want to maintain the current API, more or less. We want to have the same property names. We are going to get rid of the did set stuff because we don't need it anymore, but we're going to keep the same property names. So that refactor will have a minimal impact. So here's what it looks like. Now actually, this is the first time I'm doing the talk. I didn't get rid of did set. Apologies. So we're having the exact same API here. So we can still have the closures, but we did make current location published. Right, so that means that we can go on ahead and use this property with Combine. So whenever we assign a new value to current location, we can subscribe to it. And the same is true for location permissions. They're both published now. So building this whole object, right, even though it might have sounded complicated at first, like, oh, he's going to do like a whole location thing with delegates and all that stuff. It might sound really complicated, but in the end, it was relatively trivial because we were able to rely on the published property wrapper to actually bridge this state observation into Combine, which is extremely convenient. We can use the published property wrapper, this is sort of the point of the whole thing, to transform any property that we want in our code into a publisher. And whenever we assign something new to that property, we are notified of that, which is great. It allows us to easily observe state, which is what SwiftUI also uses it for. Right? SwiftUI uses published and other things to know when your data changed and re-render the view. And when we are done with the old callbacks, we can go ahead and simplify that object even more, get rid of the did set, change our API a little bit, and be left with this, which is really nice and convenient. And along with that extension code you saw earlier that actually implements delegate methods, we are good to go. Using the object looks a little bit like this once we're done. Right? We can say provider.$currentLocation.sync, receive value, use the current location, and again, store incancelables to properly manage the lifecycle. So you might be looking at this, and for the past, about 25 minutes, you might have been thinking, but Donny, async await will replace Combine, so why bother? Well, let's see why we would bother. Right? Let's go ahead and look at the next step and see what we can do with async await. Async await is a fantastic mechanism to perform some work and receive a result eventually. We have async stream and async sequence to replace publishers, essentially. These are both objects that will emit values whenever needed, right? So these are kind of like publishers in that sense. And with async algorithms, you can even replace most of Combine's operators, right? They have map, they have debounce, they have all kinds of things in there as well, if it's not already in the standard library. And surely there is a way to mix and match the two when needed. And sure, there is. Right, but let's take a closer look at what async await is really good at. If we take a look at what we had before, we had this code right here, right? That was the Combine-based version of a network call. And to use that, we had to do something like this, right? We call the load data function, we subscribe to the publisher that was returned, and we can receive completion values, and we have to store everything in cancelables. That's fine, it's not a big deal. If we rewrite this to async await, we didn't save that many lines of code, but this does read a lot nicer, right? We can say this function load data is asynchronous, it might throw an error, and if everything went well, it returns some model. And we create a URL, we await data from URL session, we make a JSON decoder, and we try to decode our data. Even though we didn't save many lines, I do prefer this, to be perfectly honest with you, over the future-based, or over the combined version. If we want to take it easy, because we did that with combine as well, and we don't want to migrate over to async await all at once, or not necessarily re-implement all our network calls with async await, we can also call our old callback-based code and use a continuation, right? So we can have the same method signature, load data, async throws, return some model, but we will return try await with unsafe throwing continuation. That basically is similar to combine's future, except it is not at all the same thing, but it does serve a similar purpose because it allows us to call some of our old code that is closure-based, obtain a result, and then tell the continuation to resume with that result. And whenever we resume a continuation, this function load data will return whatever we resumed the continuation with. And we're only allowed to do that once. Right? I currently use an unsafe continuation, so the runtime will do weird things if I call this more than once. You can also use a checked continuation, so that Swift will actually tell you, like, hey, you called this thing more than once. But the recommendation is, once you know that your implementation is correct, to just use unsafe, because it's slightly more performant. I have no idea if you're actually going to know this in the real world, but it is supposed to be slightly more performant. So how do we call an async await function, right? And that's where we really get benefits. We can just say, hey, model equals try await load data. That's all we need to do. No subscriptions, no cancellables, no nothing. Just get the data, and that's all. But we can't always do this. We can only do this if we are already in an asynchronous context. It is completely beyond the scope of this talk to explain what an asynchronous context is, but essentially it is a place where you can call functions that need to be awaited. If we're not already in one, we can create one by building a task, right? And this task will make us an asynchronous context and allow us to await our network call. To me, this is still nicer than what we get with combine and subscribing, right? So it's completely a no-brainer. Yes, async await will replace combine for tasks. And we have many tools in async await to orchestrate and run tasks, right? I just showed you the most basic example that I can come up with just to show you the difference for a very simple use case. Async await can also help us, or Swift concurrency, I should really say, can help us run multiple tasks in a task group. We can use async let to have a couple things going on in parallel. We are also missing some tools like a serial queue, for example, where we say, hey, we only want to run one task at a time. Or a way to say, hey, I want to run like 15 tasks, and they have to start in the exact order that I added them in. It's fine if they complete in any random order, but they have to start in order. Right, these are tools that we can sort of get in our current situation with dispatch queues, but we can't really do that with async await. Regardless, though, making something where you say, hey, this is a function, I want to call it and get its result, async await is fantastic for that. But now let's talk about async await as a state observer. Right, I showed you this code in combine. We have our current location, we subscribe to it, and we receive values. That works fine. Now, we could use async streams and sequences. I'm not going to show you how to build them. And the reason I won't show you how to build these is because there's actually a really nice way to take something that you've written in combine and turn it into an async stream, which is fantastic for people like me who just want to show you how something is done from the call side rather than the details of the inside. So let's talk about the basics of async stream first. Right, so what I did here is I used that same array publisher, right? So that is combine. And then I make a stream out of that. So I say publisher.values, that returns an async sequence. And then I map over it, and I turn those integers into strings. Right, map is just part of Swift's concurrency. It is defined on async sequence, I believe. So you can call it on any asynchronous sequence. So this is not combine's map. It's not map that you have on array. It's map that you have on async sequences. And we can loop over that, just like we can over an array. So for try await value in stream, we print the value. This looks perfectly natural, right? This is fantastic. Much nicer than the sync and much nicer than having to maintain our cancellables. So let's make it a little bit more interesting. Let's say we have our location provider, and we do for try await location provider current location.values, right? That creates that async stream of async sequence of locations. And we have for try await status and provider location permissions values. That's fantastic, right? We have 2 for loops. They get the data that we need. This is a lot easier to read than the combined version, except this will not work. Because like I mentioned, these for loops work a lot like they are an array. So if you look at the code again, if I removed the try await here, what would you expect happens? I would expect that we first go over the first for loop. Once we have obtained all the locations, the second for loop starts. And that's exactly how this code works, right? So even though the for loops themselves are awaiting values asynchronously, it's not like they can run at the exact same time unless they have their own scope to run in. Right, so this loop has to complete before this loop can start. And unfortunately, the first loop will never really complete because we might obtain infinity values. So what do we do? What we can do is we can wrap each of these loops in their own tasks, right? Because now we create a task, and the task will own the loop. We'll be looping inside of that task, and we can create another task. And these 2 tasks can now run in parallel, so we're looping over both streams of values at the same time, which is great. So we can have this one running and this one running, and they can run in parallel. So it's great that we can iterate over 2 asynchronous streams now, and you could still say, well, Donny, this is still kind of nicer than combine, let's be honest. But I didn't say that we solved all the problems. We still have issues here. Because our task lifecycle is not bound to anything. So we're kicking off these tasks, for example, in the initializer of a view model. And these tasks start running, and they start iterating over that iterator that's made by our current location values and location permission values. And they keep doing that, and they keep doing that, and they just never stop. To make that a little bit more concrete, let's look at this code. We have a view model, we create a location view model, and we set it to nil. You would expect anything that is being done by this view model to stop at this point. Except these tasks are not part of the view model. They are in their own asynchronous scope, and they will keep running. So that also means that our view model won't actually be deallocated for some reason that I'll point out in a moment. And our tasks are not canceled. So this is a big problem because we didn't have this problem before, and now we have to think about this. So what are we doing wrong? There's really 2 things that we're doing wrong here. You might notice that inside of this task, I'm saying locationProvider.currentLocation.values and locationProvider.locationPermissions.values. These are properties defined on self. For things that aren't a task in this point, Swift compiler would tell you, you are referencing a property on self. You have to be explicit in that. In this case, the compiler will not tell you this. And the reason is that tasks were designed as something that is allowed to implicitly capture self because tasks end, right? They start, they do a bunch of work, then they finish. And there's actually current ongoing discussion on Swift forums as well, where they say, well, that's all good, but not all sequences have a natural end. Some sequence might run indefinitely. So we need to be very careful with that. And also we need to have a way that whenever this view model goes out of scope, and we didn't strongly capture self implicitly, that this task will be canceled. Because if we don't do that, the task will still keep running, and even though we didn't strongly capture self, the iterator would still be going, basically, because at that point inside of the task we have a reference to the iterator that we are iterating over, and we would still be running forever. So there's 2 things when we're managing our tasks. One is we should make sure that we don't actually accidentally capture self strongly. Unfortunately, task was designed as a really good gun to shoot yourself in the foot with, because it just captures self strongly by default. The compiler doesn't tell you that it does this. You won't get any warnings. You won't get any errors. It will just do it. Your code works fine. And you are maybe thinking to yourself, this is fantastic, it works, except you have a memory leak. And also we should make sure that we break out of our iteration whenever self is gone. Right? We should cancel our task. We should make sure that our task has an ending point. So how can we do that? And this is a bit of a tongue-in-cheek solution. It's a bit cheeky because we are just going to bring combine back in because I like combine so much. What we can do is we can leverage that any cancelable paradigm that I told you about before. Whenever that gets deallocated, everything in the subscription is torn down. Turns out that any cancelable is just an object that accepts a closure that is executed in its deinitializer. So we can say on task, store this task in a set of any cancelables, and we can take that as an in-out parameter, and we can say insert an any cancelable that simply calls self.cancel for the task. This will canceled a task whenever the cancelable is deallocated, and we've cleaned up after ourselves nicely. So we can use it like this. There's a lot of code on this slide. I hope you can read it kind of okay, but it's similar to what we had before, right? So we have a task with a weak self, so we make sure that we guard that self equals self, and we store the task in the cancelables so that it is canceled whenever the view model goes out of scope. If you don't want to bring combine into this, that's completely fine. You can do that. You could also weakly capture self and check whether self still exists inside of your for loop body and just break out of it when self is nil. Similar solution, or different solution for the same problem that doesn't involve bringing combine into this. So I just talked about all that. But to me, this doesn't look that great yet. Right? We had to do a lot of work to make sure that we didn't have any issues. Tasks are definitely not designed to be safe by default in terms of memory leaks like publishers are. And these are some of the obvious rough edges. There are a couple of other things that we don't have on async sequences that, in my opinion, we do need to make them a viable competitor for combine in terms of state observation. For example, we don't have a way to mimic any publisher, for example, in Swift concurrency, which we would need. So, to summarize this, more and more companies are interestingly looking to adapt combine, but also async await, right? Even though it's been introduced in iOS 13, we're seeing, or I'm seeing, demand for this go up right now. So it's interesting to see how that is done in existing code bases. Whenever we adopt new technology, we need to do this with as minimal impact as we can, right? We don't want to disrupt our entire team. We don't want to disrupt the entire code base all at once. It really helps when we understand the patterns of features that we need to replace, right? Because we looked at closures and completion handlers first, we were able to see like, oh, hey, there's two different kind of paradigms that we're replacing here. What solution fits best? Finding ways for old and new to coexist is very important, right? That helps us avoid code duplication. It helps us make sure that we bridge things correctly. And it's always good to look ahead for alternatives and newer patterns, right? Like if you're implementing combine, look at async await. Where could async await shine, right? And right now, if you would ask me, async await shines whenever something is a task that has a very clear start and end. Combine is fantastic for state observation. And I feel like that is where we're at with combine versus async await now. And I'd like to thank you for listening to my talk.
Do you want to take some questions?
Sure, if we have time. I do feel like we went a little over, but we
a little bit.
are a little bit
That's
delayed.
Okay. That's why we have break for us, right?
Perfect.
Any questions? I have to look into the beamer to see you. There you go.
Thank you. Thanks, great talk. I wanted to ask, when you were showing the example with fetching data from the network, you ended up with this urge of migrating our existing code that uses completion or task-based URL session to publisher-based URL session or await or async await. Why is that? Why do people do that? I don't really understand what's the point, because that code already works.
Yeah.
And we can have an extension that changes it to whatever we want.
Right.
So we can just change it to being private and that's it.
No, that's also completely fine, right? That's why I showed that bridging code first, and why I think the bridging code is important, because in the end, it's up to you to decide, like, oh, hey, I have a lot of complex business logic here that works, and I don't really want to touch it. I do feel like it does make sense to sort of keep leaning with where you want to go, and also at some point change your legacy, right? Even though the legacy might still work, it does just, to me, make sense to eventually evolve everything of your code base and kind of shed all the code that you've written over the years. Right? It's not like you should refactor all your code every year, but like if after 10 years the code is still the exact same, it might just be a nice idea to refactor that also so that new people on your team understand what's going on better. Like I've literally seen code bases where there's maybe one person who can work on the core parts of it because it's still Objective-C, and it's like, oh, it still works. It's like, yeah, but literally 1 in 20 engineers can touch this. If that person leaves, who's going to work on it? All right, so that's a reason to sort of migrate over eventually.
Is there someone else?
Okay, take cover, everybody. I hope my aim is straight, so...
Oof.
Sorry. It's nice and soft, right?
Yeah.
Okay. Yeah.
Hi.
But my aim was like to the left. So go
Yeah.
ahead.
Big fan of the presentation.
Thank you.
So yeah, just basically we have in our company have some experience with this kind of migration. We're kind of familiar. Wanted to ask you, what's your opinion about Combine? Basically, what's your opinion about the future Combine? I agree that Swift concurrency have some rough edges. And for example, the composable architecture, the point three guys have quite a lot of utils written. For example, you can, on a task, you can say cancelable with ID. You can define an ID and then you can cancel it in an effect.
Sure, yeah.
So basically, once all of these rough edges are smoothed out, what do you think about the future Combine?
So I think, so right now, sort of to talk about future, I have to sort of say where I think we're at right now. I feel like right now, Combine is better at state observation. If you're doing something that involves running a bunch of tasks, getting results, right, doing a bunch of asynchronous work, that's all async await, right? Combine was never a task runner. Combine was always a pipeline of, well, here's a value, you can change it over time. It was never a thing of like, oh, do these 8 things at the same time, put them into one result. You can make it work like that, but it was never intended to be that. So in the future, I see Combine giving up that role and people stop trying to force Combine to do that, instead use async await. For state observation, I think a lot of it will depend on what SwiftUI does, right? Because I think most of state observation that we do right now ends up assigning properties to published properties so that SwiftUI can update, and Combine just has fantastic tools for that. You can probably do the same things with async await. I would imagine Swift 6 probably irons out a lot of the rough edges. You might have to ask me again at that point. But I do think that once the rough edges are gone, it will be much more of a coin toss which one you prefer.
Okay, thank you.
All right.